السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. In the name of Allah, the most gracious, the most merciful. And inshallah Rabbil Alameen, we will talk about the mass and weight. Let's go. Bismillah. Inshallah Rabbil Alameen, we will study mass and weight compared to each other because this is the best method to study them. Number one, let's talk about the definition of mass. What is mass? In fact, we used to say that mass is the quantity of matter inside the object or in the object. This definition is not accurate because quantity of matter is different from mass. Quantity of matter is measured in moles and mass is measured in kilograms. So they are not the same thing. So how can we solve this problem? In fact, we don't mean that the mass is the quantity of matter itself. No, mass is a measure of the quantity of matter. That means whenever we find an object that has a very large mass, that means it includes large amount of matter, but it doesn't mean that the amount of matter is the mass itself. Okay, so our syllabus introduced this definition. It's a measure. This is the mass. It's a measure of the quantity of matter in an object. يعني, the larger the quantity of matter, the larger the mass, and so on. Okay, but there is a very important condition to be observed here, which is that condition. It's a measure. It's a measure of the quantity of matter in an object at rest relative to the observer. Okay, to say this is an accurate description or an accurate definition, we have to add this extension. When the object that you are talking about, its mass is at rest with respect to you. If it's not at rest there, especially for very high speeds, there will be some kind of inaccuracy in your definition. So the definition of mass is it's a measure of quantity of matter in an object at rest relative to the surface. By the way, this is relative to the observer. Sorry. By the way, this is the definition of the syllabus itself. It's not. I didn't put anything from my own ideas or my own points of view in explaining syllabus in this PDF in front of you. Okay. So what is the weight? The weight is, in fact, it's the gravitational force of an object that has a mass. Okay. It's the gravitational force acting on any object that has a mass. Any object that has a mass is affected by gravity. Then we can talk about weight. Okay. Well, if there is an object that has a mass, but there is no gravity, for example, imagine that the gravity, imagine that there is no gravity, okay, in specific place. Can I talk about weight for the object? Although it has a mass? The answer is no, okay, because the weight is the effect of gravity of the mass, okay? It's the effect of gravity on the mass, sorry, on, not of, on the mass, okay? So if there is gravity, there is a weight. If there is no gravity, there is no weight. This is a very important idea, by the way, okay? But if there is gravity, there is mass. If there is no gravity, there is mass also, because the mass is a property which is related to the object itself, not to the gravity of the Earth or the planet where the object exists. Well, so we differentiated between these 2 points. Let's ask ourselves a question. We said that the gravity is, the weight is a gravitational force. So we can expect that the weight is a special kind of force. This is number one. We can expect that the measuring unit of the force is Newton, like any force. Okay. We can expect that the weight in our syllabus at least, is a vector quantity, and it's always directed downward, because in some references, in some other syllabus, yeah, not in our syllabus, okay, they say that the weight is the magnitude of this force, okay? But we are not interested in this idea. But I explain to you why did I say in some in our syllabus. Well, so this is the difference between mass and weight. Okay. Well, imagine that you are in the exam and you want to write you want to write the definition of the mass, and you didn't find all this definition in your mind. Okay. Can I write it's the quantity of matter in an object? Yes, you can write that, and you almost be awarded the mark. Okay. But it's not 100% safe. Okay. Well, what are the formulae of finding mass? We have several. Mass doesn't have specific formula, but we can find the mass from the formula rho times v. Let me remind you that rho is the density. This is rho, not b. And this is v, which is volume. This is capital V, which is different from small v. Capital P stands for volume. Small v stands for velocity. M equals W divided by G. What is W? W is the weight. What is G? G is the gravitational field strength, and we will explain them here. So this equation is derived from this equation. Okay, let me tell you that this is the weight. This is the mass. So write this in front of you. By the way, now, whenever you find the weight given in the exam, put in your mind that you may need to divide over G, which is 9.8 in our new syllabus, okay? You may need to divide over G to find M, which is the mass. So to change it from weight, and you have a weight, and you want to find the mass, you will divide over G. So in other words, we can say that if I give you the weight, if I tell you that, for example, the weight is 10 or 100 newtons, okay, and you want to find the mass for any use in the exam, okay, you will divide over G, which is 9.8 in the modern syllabus, okay? It was 10 in the old syllabus, as you remember, okay? But starting 23, we use the G as 9.8. What about the weight? Weight is a force of gravity. We know that the unbalanced force or the resultant force or the single force, okay, which is not balanced, F, equals mass times acceleration. Well, mass times acceleration. Now we want to find the force of gravity. The force of gravity. So it's the mass times the acceleration due to gravity, or the acceleration due to gravity. So the weight, which is capital W, not small w, because small w stands for work, okay? Weight equals mass M times G, which is the free fall acceleration, or it has a new name now, okay? And it's a new name for the same value, which is called gravitational field strength. Someone may say, Mister, is it free fall acceleration or gravitational field strength? In fact, they are equivalent to each other. So when I say G stands for what? G stands for free fall acceleration, and also stands for the gravitational field strength, and also stands for the gravitational acceleration. They are all equivalent, but the difference of the difference between them is in the units. Okay, the measuring units of gravitational field strength is Newton per kilogram, and you have to memorize this unit. Okay, the unit of the free fall acceleration, because it's acceleration, so it has the unit of acceleration, which is meter per second squared. And there is a surprise. We will find that Newton per kilogram is equivalent to meter per second squared. Even the units are equivalent to each other. Okay, so this is the second point, which is the formula. Regarding the units of mass and weight. Mass is measured in kilograms if we are talking about the the SI unit, and gram or tons or milligram and so on if we are talking about non-SI unit. But here we wrote the commonly used units in our IGCSE exam. Regarding the unit of weight, we said a few minutes ago that the Newton is the measuring unit. Why is it measured in Newton? Because it's a force. In fact, it's a force. Okay, well, after that, we will talk about how do we measure them. By the way, both are measured with balances. Both are measured with balances, but that depends on the scale, how scaled the balance is, or what is the scale of the balance. If the balance is scaled in kilograms, we use it to measure the mass, and it's kilogram or gram, okay, and it's called mass balance, okay, or balance. When we say balance, we mean mass balance, and this mass balance may be analog with a pointer or digital with a screen and digits on them. Regarding the measuring instrument of the weight, it's measured in weight balance, and these weight balances are mainly spring scales that are scaled in newtons. These scales are in newtons. You will find that the scale written on the balance is newton instead of kilogram. Okay, sometimes they are called force meter, sometimes they are called newton meter. Okay, or weight balances. Well, now let's go to a very important point you have to put in mind. What is the point? This point is the mass, it doesn't change by changing location. It's constant everywhere. It doesn't depend on how far or close the object is to the center of the earth, because it's something inside the object. But what about the weight? The weight, is it something inside the object, or is it the effect of an external factor, which is called the gravitational force? It's the effect of the external factor, which is called the gravitational force. So we can easily say that the weight is not constant everywhere. The weight of the same object change by changing location, changes by the weight of the same object varies or changes by changing its location. That depends on what? That depends on the gravitational field strength in this location. So if you put the same object, if you put it in a place where with large gravitational field strength, like for example close to the ground at the bottom of a mine, for example, okay, you will find that the gravitational field strength is large. Okay, so the weight will be large. But if you take the same object to a location with lower gravitational field strength, for example, like the astronaut when he is at a very high distance from the center of the earth. By the way, the center of the earth is considered to be the center of the gravity of the earth, okay, or the center the source of the gravity, considered to be the source of the gravity of the earth. So the closer to the center of the earth means the larger the gravitational field strength, okay, and vice versa, okay, the opposite is correct, okay, also. So here the astronaut in an orbit, or the object, if it's taken to the top of the Mount Everest, for example, okay, which is at very high altitude from the center of the Earth, okay, where the gravity is weaker, so the weight of the same object will be weaker. Okay, if we take the object to the surface of the moon, okay, we know that the gravitational field of the moon is 1/6 that of the Earth, yeah, which is about 1.6 meter per second squared. Okay, that means what? That means the weight on the moon is less, of the same object is less than the weight of the weight of the object on the moon, okay, will be less than the weight of the same object if it's on the Earth. The weight of the same object at very high altitude will be smaller than the weight of the object on the surface of the ground, for example. Okay, so this is the point we wrote here. If that the weight changes by changing location, okay, as why? He may ask you why, and this question, if it comes in the exam, it will be out of 2. Okay, the first mark will be awarded if you say that the weight is the effect of the gravitational field on the mass. You will be awarded the mark, inshallah, if you write this, but this is only 1 mark. Okay, why? Where the other mark? The other mark is you have to say that the gravitational field strength may change from location to another location. Okay, so this is the point. But the mass is the same on the moon, on the Earth, on Saturn, or in absence of gravity. Okay, the mass is the same. Okay, there is very important here also to be said, which is what? Mass is a measure of resistance of the object to change its velocity or to accelerate it. Okay, for example, if you have a truck, okay, that whose engine is not working, and you have a small car whose engine is working, okay, it's not working, sorry, it's not working, okay, now we want to give it a push, okay, yalla, let's push them. Which one will be pushed, yani change its velocity easily? The small car, not the truck. Okay, why? Because the mass of the car is small. Okay, so if we apply the same force in 2 objects, the smaller object, as we will study later, inshallah, the smaller object will be given a very large acceleration, or will be given larger acceleration, but the larger object will be given smaller acceleration. Okay, so it's difficult to change the small, the larger mass, but it's easy to change the speed of larger mass. Okay, but it's easy to change the speed or even the direction of the smaller mass. I hope it's clear, inshallah. Rabbil Alameen. Well, now let's go to, we finished the explanation, and now inshallah we will apply some questions on this. But before going to applying questions, let's talk about these important points that we postponed from the table. Okay, we said that the gravitational field strength. What is the definition of the gravitational field strength? This definition is very important, and the syllabus, the new syllabus, asked you to memorize it well and put it in mind. The gravitational field strength is the gravitational field, the gravitational force on each 1 kilogram of the object. Yani, is the gravitational force per unit mass. So now, please bring a pen and a copybook and write the gravitational field strength on an object, on all the object, is the weight. But the gravitational field strength per unit mass, yani per 1 kilogram, is the gravitational field strength. Again, the gravitational force on the whole object is the weight. The gravitational force on each kilogram of the object, or per unit kilogram, per unit mass, per 1 kilogram, is the gravitational field strength. And we said that the gravitational field strength is given the symbol G. And we said that G equals W divided by M. From where? From this formula. Let's agree together that we have this triangle, okay? The subject is placed up M and G are placed here. So if you want to find G, G will be W over M, and that's what we did here. G, which is the gravitational field strength, equals W, which is the weight in newtons. G is weight divided by mass. The weight is measured in newtons and mass is measured in kilograms. So the measuring unit of G is Newton per kilogram. Note that in this formula, W equals mg, mass must be in kilograms. It's not allowed to use mass in grams here. Several times I told you that in RGCSE exam, you can use SI or non-SI units as you want and according to the context of the question, except for in some positions or some situations, you will not be allowed to use any unit rather than the SI units. Okay, and I told you that I'll, inshallah, tell you about these positions. This is the first position, which is the position that requires using all SI units in all the quantities in the equation. This is the first equation, W, not the first, yani, this is one of the positions, W equals mg. And its twins, which is F equals ma. These two equations, and we will study also, inshallah, later, other questions, you have to use the SI units. So if the mass is given in grams, you have to change it to kilogram. If the mass is given in grams, you have to change it to kilograms. Well, for example, let's see this question here. Question 7, this one. You will find this question when you are solving the homework. Okay? Question says, the mass of an empty beaker is 400 grams. Well, I have no problem with the grams. Generally, I have no problem with the grams, but he is asking me to calculate the weight. Oh no. Once you see the weight, number one, you make sure that the mass is in kilograms, not in grams. Okay, so the mass here, you will say that M equals 400 grams. To change from grams to kilogram, you have to divide over 1,000. So it will be 0.4 grams, kilograms, sorry. So this is the first mark. This is the first mark. You will divide 400 over, there is some delay in the internet, sorry. Okay, over the, yes, over 1,000. Well, this is the first mark. After that, you would write the formula W equals mg. This is another mark. Okay. After that, you will substitute with correct substitution. Okay. So you will say that M is 400. And after that, you will substitute G, which is 9.8, for example, for the new syllabus. Okay. After that, you will find the correct answer here. You will write the correct answer here up to 2 significant figures. In fact, it's 2 or 3, but it's preferable to use 2 significant figures in paper 4. Okay, and you have to put the measuring unit, which is Newton. If you don't put the Newton, you will lose a mark. Okay, so this is an example of solving this issue regarding the unit. Well, now we said that the gravitational field strength or the gravitational acceleration and the free fall acceleration are equivalent to each other. How can we see that? This is the gravitational field strength value G equals 9.8 Newton per kilogram. So it's 9.8, but it's a Newton per kilogram. The gravitational acceleration or free fall acceleration, it's what? 9.8 also, but it's in meters per squared second. Okay, and we will see, inshallah Rabbil Alameen, that even the Newton per kilogram, it's equivalent to the meter per second squared, but this is not our point for now. At higher altitudes, farther than the center of the Earth or on the Moon, weight of the same object is less compared to its value of the ground on the ground, but mass stays the same everywhere, as I told you, and we explained this point, but this is the answer written here. Weights and masses may be compared using balances, as we explained. After studying this, you can solve the practice questions that I'll send to you, these 1 and 2, and inshallah I will see you in the next video. Thank you. Assalamu alaikum wa rahmatullah.